I've got a test set up to start testing the discharge capacity of these Tesla modules. A lot of people will use an iCharger like this to run a regenerative discharge. The issue is I have 6 modules here, all at 100% state of charge. So I can't dump the energy from one into another because I'll overcharge the other. So first, I'm going to discharge one of these and not record the values. So that I'll have one discharged, and then I can regeneratively discharge through the iCharger and go in a circle and have one feed the other, then one feed the other. So just for this test, I bought one of these Overkill Solar BMS boards to replace the Tesla board. The Tesla boards, here's a stock one. You can't read the voltages off of them. There's a connector up here, but there's logic on board that you can't read directly off of. So I got one of these boards, which essentially takes the cell voltage wires, ribbons from here and here, and puts it into this terminal here. Now I thought this board is kind of silly. It's just converting voltages you already have in 2 connectors down to 1. But I looked into it, spent a lot of time, and the mating connectors for these aren't easily attainable. They only cost like 50 cents, but you got to buy like 200 of them, so it doesn't make sense. So I got this board. There's tons of videos out there on how to remove the old boards and put on these boards. This one I like the best. It's the cheapest. It's only $25. Others were 30 to 50. And what's really nice is that this has clamp down screw terminals here. There are other boards that have the same Molex upper connector like here, but then the issue is you have to buy that connector and contacts and crimper. So this is super easy. You can run any wires to it. So for this initial discharge, I bought a cheap Amazon BMS for 15 bucks. There's a battery plus and minus, and then a load plus and minus, and then individual cells. So I'll be running through the BMS, discharging down to these 24 volt heaters. Now these are submersible, so that's how I'm dumping my energy, is heating up this water. So I've got 2 of these in parallel running out of the load port of the BMS. So these are 485 watt each, about 900 watts total. I did some math in this 5-gallon bucket. It might actually come close to boiling within about 2.5 to 3 hours. And if I'm discharging at 900 watts, and this is a 5,000 watt pack, that's going to be at least 5 hours. So I'll have to monitor this and make sure we're not boiling and splashing water. What's cool is these won't work at less than 20 volts, which means I can't fully discharge this battery, because once I get low enough, I'll get below 20 volts, still have some charge left in here, but the heaters won't work anymore. And then this BMS is just also a parallel failure mode. So I have 2 things that would have to fail for something to go wrong here. So this BMS actually measures all the individual cell voltages to see if anything gets too low, and it'll cut power out to the load and the heaters. This is my super cheap way of running this initial discharge. These heaters are $5 each. Another more elegant way to do this would be to run this to an inverter and then run a heater or something and do it much faster. But the issue is I'd have to have a 24 volt inverter, and that would be expensive. That'd be like $200-300 just for the inverter. So here's my roughly $50 version of doing the same test, and a lot of these components I can use in the future, like this BMS, maybe these heaters, and this board. So I connected the positive. The test has started. I can feel the heat coming off the top of the water. And then when I touch my bracket here, it's not hot on the ends. So I know it's going well. It's running all the heat straight into the water bucket. And I'm feeling my wiring, and nothing feels hot. Nothing even feels warm, actually. So that's good. Before the test started, this was at 25.1 volts. As soon as I hooked up the load, it dropped to 23.5 across the terminals. I don't know if that's normal. Maybe that's a sign that these cells are pretty wrecked. That kind of voltage drop for a Less than 1 kilowatt load. Can't imagine how much voltage drop there's going to be with the car at like a 50 kilowatt load. So that's why I'm testing these. On second thought, there's probably that voltage drop initially because at the start of the curve, the voltage drops heavily. It goes from 4.2 down to 3.7 pretty quickly. So maybe these are okay. Water's quite warm. We've got the world's first Tesla hot tub right now. That's like at least 120. 1 hour in, you can see the water steaming, but it's not boiling. Voltage has dropped from the cells in the past hour from 3.92 to 3.86 volts. This is hour 2. It's definitely steaming more. And I see boiling happening just on the heater itself. I feel the side of the bucket and it's warm, not super hot. Down at the bottom, it's almost room temperature cold. So I'm not too concerned about this boiling. And now it is at 3.80 volts, so losing 60 millivolts per hour on the cells. I just disconnected the battery positive to stop the test. Water level dropped a little over an inch, so quite a bit steamed, evaporated, boiled off. The bucket's still very warm, over 130 degrees. I stopped it once the battery voltage hit 21 volts, about 3.5 volts per cell. That's roughly the 20% remaining capacity mark. So it took about a little over 5.5 hours to get there. So with my math here, on the heaters themselves, they're marked 485 watts at 30 volts. So that's 16.2 amps. Since I'm running at 24 volts, I multiply that 16.2 amps by 24 volts, and I'm actually estimating I was probably pulling 390 watts per heater, times 2 heaters, 780 watts, times 5.7 hours is 4.45 kilowatt hours is my estimate of how much energy the heaters took. Then based on the fact that I stopped at 3.5 volts per cell, 20% remaining, the batteries are rated for 5.3 kilowatt hours times 80% of that I used. The battery should output 4.24 kilowatt hours. And my estimates are I consumed 4.45. So something's slightly off in my estimate here, or the batteries are holding more capacity than they're rated. Either way, these are very close numbers. So now it's off to step 2 of the test. Now that I have this module discharged, I can run the iCharger to charge this one regeneratively into this one and track with the power meter on the iCharger to see exactly how much capacity this battery holds when it discharges into this one.